I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to discuss arc cosine, sine inverse x, and also graph when it is transformed, right? So you can see the transformations also. We are considering mainly horizontal transformations in this particular video. In the playlist, you'll have wide variety of sketching graphs for trigonometric inverse functions. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top. We can be part of your success story. Now, let's look into cosine function first and then we'll get into the details. So I'm first sketching a sinusoidal wave, right? So that's my sinusoidal waves. Now, when we say cosine, it starts with the maximum. So let this be the starting point, and then let this be the y-axis, x-axis. So this is x and this is y for us. The cosine wave starts with the maximum. So 1 at 0 and minus 1, so it's not to the scale, at pi. And at 2 pi, we again have 1. So that is the cosine wave. If I draw a horizontal line, it is going to cross at more than one point. And therefore, inverse of cosine function is not a function, right? To make inverse a function, we have to do a restriction on the domain of cosine function. So the restriction done is we only consider from 0 to pi. So this half graph of cosine, that is the restricted domain. So now our domain for the cosine function has been restricted from 0 to pi. Well, those of you who are working in degrees can write 180 degrees. Now you can see in this domain range is from minus 1 to 1, right? So full range is there. So all the values which cosine can take, for that we can have an angle, right? But will work only in the domain of 0 to pi. So whenever you have questions where you have to evaluate something related to cos inverse, always look into only the domain which is from 0 to pi. Does it make sense? Means in quadrant 1 and in quadrant 2. As you know, in quadrant 1, all are positive, right? But in quadrant 2, sine is positive, not cosine, right? So that is the cost rule for you. So now we understand that we have restricted the domain of cosine function to ensure that its inverse is a function, right? Now if you take the inverse, then the domain and range will swap, correct? So for inverse, as we know, let me write down. This is the basic concept. So the domain for the inverse, so we'll write cos inverse x, will now be from minus 1 to 1, and the range will be from 0 to pi. Makes sense? Correct. So with that in mind, we are going to sketch the graph of inverse cosine function. Perfect. And then to do question number 5 and 6, we'll do the transformation of that particular graph. Now this is from 4, 5 and 6, 1, 2 and 3. We had a similar discussion on sine functions with different types of transformations. So the idea is to learn all about transformations with trigonometric inverse functions with 6 examples, 3 of them of each primary trigonometric ratio. So I hope it is making sense. Now also you will notice that I only considered half of the unit circle. Now, half of the unit circle, because as you can see, we are working only in the domain from 0 to pi for cosine function. So, all the values required are provided here. As you know, x values represent the cosine values for the different angles given inside the unit circle. Perfect. So, that becomes your reference frame. Many students are used to using unit circle. You can use that. Most of you, which are my students, definitely use special triangles. So I'm making a special triangle here also. So we use these two special triangles most of the time and the cast rule, correct? So we use these two things, cast rule, to get the values and the special triangles. Pi by 4, for example, we'll have 1, 1 square root 2. And pi by 6, pi by 3 will have 1, 2 square root 3, correct? So you may use special triangles or the unit circle to get the values for sketching the graph. So rough sketch I will be providing. So I hope it is all making sense. It's very interesting to see how we are only using half of the unit circle so that we have removed all the clutter, right? So everything which you need is there on the screen. Makes sense, right? So I hope it is absolutely clear. If any doubts, feel free to send your questions on the email globalmathinstitute@gmail.com. Now let's get back to sketching, right? So we just realized that for cosine function, we have a domain which is from 0 to pi, right? So let's write down cos x here. So for cos x, the coordinate points which we are interested in will be from 0. At 0, it is maximum value of 1. And then at pi by 2, we have a 0. And at pi, we have minus 1, the minimum value. So it is always decreasing, right? Correct. To, in, to sketch our cosine, let me write another ink, right? What do? We swap x and y values, and therefore what we get here is value 1, 0, right? 0 pi by 2 and minus 1 pi. Correct. So you should also have in mind what is pi, right? So let's write down the value of pi. Approximately it is equal to 3.14 and pi by 2 is half of it, correct? So 1.57. So these are the approximate values of pi and pi by 2. So you get an idea that pi is more than 3 times 1. So that gives you kind of a scale, right? So I hope the concept is clear. We have the points with us. We have the points for cos x and cosine inverse x or arc x. Now let us try to sketch the graph for the same. So let me make a scale here. Most of it is on the upper half and therefore I'm drawing a line here. And there you go. So that is my x and y axis. Let's put up a scale. 1, 2, 3. 1, 2, 3, correct? Minus 1, correct? So these are each units of 1, correct? Now, as you know, pi is 3.14 and pi by 2 is 1.57. So at 1, we have a 0. So the first point for the cosine inverse will be right there, right? So we have taken up this point, which is at 1 we have 0. Now at 0, we have pi by 2. Pi by 2 is 1.57, right? So that will be our second point. Is that clear? And at minus 1, which is right there, we have pi, which is slightly more than 3, correct? You get the idea. So the graph will be kind of like this. So that is the graph of cos inverse x or arc cos x. Is that clear to you? So this point right on the top is actually minus 1 pi. And that point here is 1, 0, the x-intercept in this case, right? So that is cos inverse x. I will also sketch on the same scale the graph for cos x. So cos x was 1 here, right? 1. And at pi it was minus 1, correct? And pi by 2, which is more than 1, it was kind of like this. You see that? That is the graph of cos x. So cos x graph, which was from 1 to minus 1 and from 0 to pi, has been reflected on the line, which you know is y equals to x, to give you the inverse. Now you can very clearly see how we sketch the inverse of cosine function, correct? So the critical points to show are those which are shown here, right? So pi by 2 is the y-intercept, 1 is the x-intercept, and the maximum point is minus 1 pi. Clear? So with that we have done question number 4, which is sketching arc cos x. Now, for getting more values, you could have, so we use these values. At 0, we use 1, correct. And at pi by 2, we use swap this value and pi. So in the unit circle, only quadrant 1 and 2 takes care of cosine inverse function. Is that clear to you? Now let's do part B, right? So let's rewrite the values. R cos x are, so at minus 1 we have the value of pi, then at 0 we have pi by 2, and at 1 we have 0, correct? Now we need to sketch the graph of r cos x minus 2. So what really happens? The coordinate points x, they move right 2 units, right? So translate 2 units right. Clear? So that means the x values will change, right? So the x values will now be plus 2, right? So x plus 2. And the y values will remain same. So let's write the new x values. Adding 2 to minus 1 will give me 1. Pi will remain as such. Then here will be 2 pi by 2. And then here it will be 3, 0. So these are the new values. Put them on the graph. I've already taken the graph of cos inverse x. Right? So we are going to shift each and every point 2 units to the right. So the first one, which is minus 1, goes to 1. Right? Okay, so this is where it moves. Okay. The second one goes to 2. Correct, so it moves here. The third one goes to 3, slightly less than pi, right? And connecting them, we have our graph. Is that clear? So that is how we are going to sketch the graph of cos inverse x minus 2. Make sense? Easy? Perfect. So with that, we have understood how do we take advantage of the cos inverse x and then sketch transform functions. At this point, I like to thank all my viewers and subscribers for watching my videos, posting excellent comments and suggestions. Some of you have been contributing. As you know, we provide absolutely free services, that too since last 15 years with more than 17,000 videos. The quality education which we provide is accessible to many students worldwide, more than 80 countries. Many do not have much privileges as you have. If you can donate and contribute, help towards quality education, please do contact me on the email address given here. Perfect. And now we are going to take the last part of this question, which is again a horizontal transformation. I hope you can sketch it on your own. Some of you must have done it by now, right? So let's see. How do we sketch arc cos x by 2? First step, what is the transformation? Well, it is horizontally stretched by a factor of 2, right? Reciprocal of half, which is 2. So we are looking for a wider graph, right? Okay. So again, begin with arc cos x. So let me write down the coordinate points for arc cos x. This is going to be a process, correct? Starting with minus 1 pi, correct? So the numbers and the radians, right? Do you see? It becomes easy to do it, right? You get the idea. And then we'll write down this time arc cos x by 2. So the x value will double up. So minus 1 becomes minus 2. The y value remains same in this particular case. 0 will not change. And I mean the y-intercept. The 0 will become at 2, right? Okay, great. So what you literally see is that the maximum moves one more unit towards the left. Y-intercept remains there. The x-intercept moves towards the right. And so we have a stretched function. Is it clear? So in the previous one, where there was only a translation, the shape was just exactly the same. They were congruent graphs. Now we have a stretched horizontal graph. Correct. So I hope this makes it simple. You could have any function, just convert points using the transformation. In this case, the xy values were changed like this, correct? And we got it. So I hope with this simple process you have understood completely how do we sketch graphs for cosine functions. Now, question for you. For the next video, it is how do we sketch the tangent functions, inverse of tangent functions, and their transformations. I hope you are enjoying this journey of learning. Go to our playlist and explore. Thanks for your time and all the best.